Hello there. It's about time we got to chapter 3, right? You've probably finished the test and you're ready to move on. Now this we're going to do a little bit differently. We're going to split up the product and quotient rules into 2 videos. We're going to hit the product rule first, and we'll come back with the second video, 3.1b perhaps, and call it the quotient rule. They are different, and you have to make sure you get the product one down solid so that you recognize the difference between the two and don't get them mixed up. So here we go. Product rule. Ready? Set? Go. Alright, what I've done is I've put some links in here, and this I think will be in Moodle. If you don't see them in Moodle, let me know. I'll check a little bit later. Those are 3 links that you might like to check those out. A review for the power rule, and a link for the product rule, and also a link for the quotient rule. Sometimes it helps to see it from 2 different angles. Here's your chance. So we're going to take just the first part, and while we're here, I'm going to turn on the pen just in case I find a reason to notate something. So we're working on this one. Actually, put a check mark. You can put whatever you like though. Alright, here we are. Now, the next couple of slides can get a little bit confusing. There's so many different varieties they show you. What you need to do is pick out one that really resonates with you, that's easy to remember. This one I sort of like in a way. It's not too complicated. And let's see, where's my marker? Okay. Somehow I'm missing my pen. Let's see if this helps. Does that make a difference? Okay. Let's do it with the mouse then. Alright. Here's the product rule. Number 1, you go to function. We'll call it y. That function is created by multiplying 2 other functions. A function called f, a function called g. You can call them whatever you like. We just got 2 different functions. If you really wanted to, you can call them f1 and f2, but that might be confusing. I like this way. So here's one way of looking at the product rule. First of all, you've got these 2 functions, f and g. You want to find the derivative of the product of them. So take the first function, multiply it because it's the product rule, but multiply it times the derivative of the other function. And you add the 2 together, that's critical, and then reverse the 2 roles. Instead of g prime of x, which you had in the first part, you have just g of x, and then times the derivative of the other one. So in short, this means to get the derivative, you're going to take each function and multiply it times the derivative of the opposite function, and you'll add the 2 products together. If you wanted to make this a little bit shorter, maybe you'll like this one instead, this version. Same thing anyway. F times g prime plus, and I'm going to keep them f and then g. So you reverse the roles, so f, you take the derivative of in the second part, and g stays as it was originally. F, g prime, f prime, g. If you like this, good. If you like this, good. Whatever suits you allows you to remember it just a little bit better. This is a little bit nuts. But if for some reason this helps you, go for it. Again, Here's one function, derivative of the other one. Add the two results. Second one, you have the second function and the derivative of the first function. It's all the same thing, really. This just uses different notation. This says take the derivative with respect to x. And the derivative is of a product of two functions. And there's the first function, derivative of the second. Second function, derivative of the first. This is one of my favorites. There's another one. This uses entirely different notation. But what this represents is big D for derivative. And this small number says we're taking the derivative with respect to x. And all the rest is the same except the notation. This is just saying take the derivative, take the derivative. I like this one. Short and sweet. The only thing I would do myself is I would probably put both the f's first and the g's second, but that's a personal preference. You pick whichever one you like and you stick with it. So how does it work? All right, here's why. And pardon me, my pen doesn't seem to want to work. So, oh, I know why it won't work. I didn't have it plugged in. Imagine that. All right. Back here. And somehow lost part of this. This is crazy. Let's see if I can restart this thing. Discard. And we'll go back here. Start that up again at the same place. Okay, let's see if we're going to get this working again. So here's my pen. Make sure it's going. And now slip to the actual pen instead of the mouse. Where am I? Here we go. Okay. So here's my function. It's the product of two individual functions. You can call this f and this g if you like. I'm going to slip up here for a moment. And I'm going to erase that because I might need that space. So, setup. I want the derivative. We'll call it y prime, just to keep the space at a minimum. Now, we want each of these times the derivative of the opposite. So, I'll take x squared plus 3x minus 1. It gets multiplied times the derivative of the other one. And I'm not even going to do it yet. I'm just going to write down the second function. And I'm going to take the derivative of that. See that? For the product rule, we put an addition between them. Remember that? Now I'm going to write the same functions down, but take the derivative of the opposite one. So of x squared minus 3x minus 1. And I'm going to take the derivative this time because I didn't over here. And that times x cubed minus 8x. And since I take the derivative over here, I don't over there. Next step. Y prime, the derivative. Well, this first part stays the same. X cubed plus 3x minus 1. Now I take the derivative of this. Should be pretty easy for you by now. There's the derivative of function g, if you like to call it that. Next, we're going to take the derivative of the first one. The derivative of x squared is 2x. Minus 3x gives us a minus 3. Negative 1, you get a derivative of 0. And then we're multiplying it times the second function, x cubed minus 8x. That should be the hard part. Now, a lot of cleanup, if you want to call it that. First of all, we're going to multiply the x cubed times the terms in here. So if x cubed times 3x squared is 3x to the fifth. X cubed times minus 8 is minus 8x cubed. I'm going to make a little mark down here so I know that I've used the x cubed. Now I'll multiply by the 3x. 3x times the 3x squared will give me 9x cubed. And 3x times minus 8 will give me minus 24x. I've multiplied by the 3x, check that off. And then, since I'm multiplying by minus 1, all I have to do is change the sign of each one of those two. So I have minus 3x squared plus 8. Notice both of those have changed sign from here to here. So I've multiplied with all three of those terms. Now it's time to move on. Second side, I'm just going to make a little mark here. Starting the second side, 2x times x cubed will give me 2x to the fourth. 2x times minus 8x will be minus 16x squared. So I've multiplied by the 2x. Now by the minus 3 times x cubed is minus 3x cubed, and the minus 3 times minus 8x will be plus 24x. And I finished multiplying by that. We should be ready to move on. Now, barring any mistake, let's see what we've got. As I look through here, the only x to the fifth term I've got is the first one. So 3x to the fifth, and we used up that one. So I have an x to the fourth, yes, I've got one x to the fourth there. So that's 2x to the fourth. I used up that one. Now let's look for x cubes. I've got one here and one here. If I add those together, I've got positive 1x cubed. And I've got another x cubed here. And a positive 1x cubed to that. And I'll have minus 2x cubed. So I've used up this, and this, and this. Now I'm going to look for the x squares. I've got an x squared here, minus 3x squared, and a minus 16x squared for negative 19x squared. So I've used up this, and I've used up that. Next, I've got the x terms. I've got a negative 24x and a positive 24x. Well, that's 0. So those give me 0, nothing to add down here. And all that's left is an 8, so plus 8. And that should be our derivative. And just a note, if you call that f of x, this would be f prime of x. And you can also call it dy dx. That's quite handy at times too. So let's do a few clicks here and see what the slides look like. They may do something a slight bit different, we'll see. So they made this look a little bit different, and I guess you can't see that. So let me clear all the ink on that slide. There we go. So here's the first function, derivative of the second, plus the derivative or the second function and the derivative of the first. So they've got them reversed with the function first, the derivative second. And do some multiplying, just like we did. And that should be what we have, if everything went right. I don't have a list of it. All right, let's try another one. So we've got f of x, just like we had y before. Here's one function, here's a second function. So the first thing I'm going to do is something that I mentioned the other day, which is very handy quite often. Before you actually get rolling, rewrite the whole function. I know that I'm going to be taking the derivative of this product, so I want these ready for the power rule. So in the first one, this can be written as x to the 1/2. So it's ready for the power rule. Plus, this is already for the power rule. And the other one, we're still good. We're ready to roll. Now, yes, we could multiply these together, then take the derivative, but we're practicing on the product rule. So, if I want f prime of x, or dy dx, I'm going to write this one as it is, and that's times the derivative of the other one. Now I'm going to just take the long way around, so I'm sure that you're following me. This one, I'll take the derivative of. With the product rule, we've got a plus between the two products. Then we'll reverse the roles. The first one is x to the 1/2. I'm just copying from up here. Plus x to the -1. Now I had this directly before, just a straight copy. This time I'm going to take the derivative of that, and then I took the x squared plus 1, took the derivative the first time, so I'll just write it directly this time. F g prime plus f prime g. All right, so what does that give us? We'll get a little bit further in this. We've got x to the 1/2 plus x to the -1. Now I need to take the derivative of this. Well, that's pretty simple. Just 2x for that whole thing. That's nice. Second, I need to take the derivative of this first one. So bring the 1/2 out front. 1/2 x, and subtract 1 from this half. So I have -1/2 plus the derivative of this. I'll have a minus out front, so I'll just make that a minus x, and subtract 1 from this. Don't make it a 0. It has to be a -2 because you're subtracting 1 from the -1. And then you've got the x squared plus 1. Now you're ready to start multiplying. So, using the other notation, we throw in dy dx, just so you see it more often. All right, in the first one, you could think of this 2x as being out here if you like. So 2x times this, you have 2x, and you've got an x to the half, and x to the first, so it'd be x to the 3 halves for this times this. And we need to multiply the 2x times this one, which will give us 2x, and -1 plus a +1 is 0. so we don't need that at all. X to the 0 is a 1. So we've got the first part. What's the second part look like? Alright, we're going to take this 1/2 x to the minus 1/2 times the x squared. So 1/2 times 1 is 1/2. X to the minus 1/2 times x to the second power of the square. Add those two exponents of x to the 3 halves. And we just saw that over here, so we know we're going to be combining those. And then we'll take this half x to the negative 1/2 times the 1, and that's pretty simple. 1/2 x to the negative 1/2. So I've multiplied by this, so I'm just going to make a mark there. So negative x to the negative 1/2. So negative 1 times 1 is negative. And we've got x to what? Well, if I add those exponents, I get 0. So what I've actually got here is just a 1. It'd be like x squared over x squared, but there's a minus sign out front. And then this minus x to the negative 2 times 1, very simply negative x to the negative 2. Just copy that down. And let's see what we've got. dy dx. The largest exponent appears to be 3 halves. No, negative 2. Actually, that's going in the other direction. So we'll start with this one. We've got a pair of these x to the 3 halves. So we can add those together. 2 plus 1/2 is 5 halves. So 5 halves x to the 3 halves. And that's this and this. 2 plus 1/2 is 5 halves. There's a 2 there. Okay, so those are gone. I've got an x to the minus 1/2, so plus 1/2 x to the minus 1/2. So also taking care of that one. I've also got this one, minus x to the negative 2. Takes care of that one. And I've got a 2 and negative 1 for plus 1. And that probably is given as our derivative. We could rearrange some things. We could make this, for example, 5x to the 3 halves over 2, if you wanted to. And this one has a 2 on the bottom. And because this has a negative exponent, we can put x to the 1/2 down there. Or if you wanted to, you can make that the square root of x. And this has a negative exponent, so this would be minus 1 over x squared, and plus 1 at the end. And we should be in business with that. All right. A little bit of practice, you'll be an expert too. And that's what it looks like, slide-wise. Notice one function, the derivative of the other. The other function, the derivative of the first one. The plus between them. To do the dirty work, do the multiplying, and add any similar terms, and you got your answer. And you might want to write like this. Either way, it depends on how you're going to use it. In some cases, the square root might be more convenient for you. In other cases, it might be easier using the negative exponents. It all depends on the situation. Well, that's it. The product rule, and you should be ready to roll. practice some of those, bring your questions to class, and I'll see you next in, you know what, the quotient rule. But get the product rule down solid, because the quotient rule looks a little similar to it, but you have to make sure you don't mix some of those things up. Remember, very simply, if you want dy dx and y was f of x times g of x, so f times the derivative of the other one plus, that's big, and then f prime g. Reverse the roles. That's the way I like to think about it, because I've got fg, and each term has the derivative of one of those. I'll see you soon. Bye-bye.